All right, let's dive right in. We're going to talk about something from the absolute edge of physics, a concept that seems to shatter the most basic rule of reality we know. It's called quantum retrocausality.
I mean, seriously, just stop and think about it. Everything in your life, everything you've ever seen, tells you that cause comes before effect. But what if it didn't? What if the future could actually reach back and change the past? That's the rabbit hole we're going down today.
So, let's start by challenging something we just accept, the arrow of time. You know, this idea that time only moves forward, past, present, future. Simple, right?
In our world, the big, clunky, everyday world, things are simple. You throw a rock, it causes a splash. The rock hitting the water always comes first. It's a straight line. It's how we think reality works. But, and this is a huge but, when you zoom way, way down to the quantum level, we're talking individual particles here, that whole rulebook just gets tossed out. It's a completely different game, a weird, spooky game that messes with your head.
Okay, so what do we actually call this wild idea? It's got a name, and it sounds pretty sci-fi. Retrocausality. Let's unpack what that really means.
Basically, quantum retrocausality is the idea that cause and effect isn't just a one-way street from past to future. It's the mind-bending proposal that something that happens later can influence something that already occurred.
Think of it this way. Normally, we see time as a one-way street. Past leads to future. End of story. Retrocausality says, hold on, what if it's actually a two-way street? What if influence can travel backwards too? So you're probably asking, how on earth could that work? Well, one of the main theories is called the transactional interpretation. The best way to picture it is like a handshake across time. Imagine a particle sends out an offer into the future and another offer into the past. And only when those two offers connect, when they shake hands, does the event actually become real.
Okay, I know this sounds like we're just talking crazy philosophy here, but here's the thing. It's not just an idea. It's been tested. Let's look at one of the wildest experiments in the history of physics.
All right, hang with me. This gets a little trippy. You start with two connected particles. Let's call them A and B. Particle A zips off and hits a detector. Bam, it's done its thing. Now, after that has already happened, a scientist over here makes a decision about particle B. They can choose to find out which way particle A went, or they can choose to erase that information. The key part, the choice about B happens after A has already finished its race.
And this is where your brain starts to melt. The choice they make about particle B in the future seems to change what particle A did in the past. I'm not kidding. If they erase the info, it turns out A acted like a wave. If they don't erase it, A acted like a particle. A decision made now seems to determine what already happened. And listen, this isn't some new, unproven thing. This experiment was actually done for real back in 1999. For more than 20 years, physicists have been staring at these results, scratching their heads, and wondering if we've had time completely wrong all along.
So if the future can change the past, what does that even mean for, everything? The implications here are just staggering.
This is where it gets really deep. I mean, think about free will. If your choices today can affect yesterday, are you really choosing? Or is everything already written? It leads to this idea of a block universe, where the past, present, and future are all equally real, just existing, like frames on a strip of film.
And this debate has been raging for a long time. You've got philosophers on one side saying, hey, there's no law of logic that says a cause has to come first. But then you have the counterargument, the big one, which is basically the grandfather paradox. If you could see the effect, couldn't you just decide not to do the cause? It's a real head-scratcher, and people are still arguing about it today.
But okay, let's pull back from the deep philosophy for a second. This isn't just a thought experiment. It could have real, tangible applications. How could this idea of the future of the past actually change our future?
If we could actually get a handle on this, we might be able to develop technologies that feel like straight-up magic right now. Not to mention getting a much deeper handle on how the universe actually ticks. Take quantum computing. What if you could design an algorithm that, in a sense, already knows the answer, because it's getting a hint from the future? That would be a revolution, and it would open up whole new ways to poke and prod at time itself. It might even be the key to finally connecting quantum mechanics with Einstein's relativity, the biggest puzzle in physics.
So that leaves us with a pretty big question, right? We all grow up thinking of time as this river, flowing in one direction.
But the quantum world is telling us it might not be that simple. If time isn't just a one-way street, well, where does that leave us? It suggests that reality is a whole lot weirder and more connected than we ever could have dreamed.